Welcome to Engage Math, Lesson 33, Problem 1. One of my favorite lessons because we are trying to look at some of the most common algebra mistakes that students make. And we're going to go through them, so hopefully you'll avoid them as you move on in math. All right, I'm going to zoom in so we can see this really nicely. Let's get started with the first one. Circle the larger quantity. Most people think, and each time I'll tell you what the common mistake is, that, oh, if you're dividing, that's going to make the number smaller. But not when you're dividing by a fraction, because 5 divided by 1/3 is the same as 5 times 3 over 1. And if you want, you can put the 5 over 1. So you would get 5 over 1 times 3 over 1 is simply 15. So this is 15, whereas the second fraction is going to be 5/3. So the larger quantity, I'm going to circle in blue, is 5 divided by 1/3. Common mistake is to forget that when you divide a fraction or how to do it, but when you do it, you have to keep the original fraction or make it into a fraction. In this case is 5 over 1, change to multiplication, and then take the reciprocal of the second fraction. Okay, let's look at B. So one of these equations would always be true, and the other one, depending on the value of x or y, maybe you could make it true, but it isn't always going to be true. So what I want you to see is that this is true because when something is written as x plus y over 2, it really means to take that x and divide that by 2, and then to also divide the y by 2, which is why this is the correct way to write it. I have a little expression that I love to use for this particular problem, and it's sharing is caring. The reason is when there's 2 or more terms in the numerator over a single term in the denominator, what we do is we can think that each one of those terms in the numerator have to share the denominator. So it's kind of that heart shape because of sharing is caring, and it becomes x over 2 and y over 2. This is correct. So it's this that you should circle. Okay, let's move on to C. All right, 3 cannot be divided by 0. Nothing can be divided by 0. This is undefined. The way I want you to remember that is to think, no, you cannot divide by 0. No, that is undefined. So NO, 0 in the denominator is not allowed. Okay, 0 divided by 3, that could be written this way. And 0 in the numerator over anything except for 0. So 0 over 3 or 7 or 5.1 or a million is going to be 0. This is okay, just as a way for you to remember it. 0 in the numerator is equal to 0 as long as the denominator is not 0. Okay, the reason that these two are here is these are very commonly mixed up. Remember, we are adding to 6 and multiplying to 5 to factor this. So the two numbers that work are 5 and 1, so you have x plus 5 and x plus 1. Whereas here, we're multiplying to 6 and adding to 5. So we add to 5, multiply to 6. The two numbers that work there are 2 and 3. So this would factor as x plus 2 and x plus 3. And remember, it doesn't matter which parentheses you put first. Okay, let's go to G. I'm going to kind of move up and make that nice and large for you so you can see some of these. 3 squared times 3 to the 4th. A lot of people want to say that that's 9 to the 6th, but what we do is we just leave it as 3 to the 6th. And the reason is, it's so tempting, I know, to make it 9, but what we do is we really have 3 times 3, which is 3 squared, and 3 to the 4th has the 3 4 times. So altogether, we have 3 to the 6th. This here, we again leave the 3, but it's going to be 3 to the 8th. Okay, so we just multiply those exponents. Okay, let's look at I, J, and K, and even L we'll look at in a minute. But a lot of times I hear students say, oh, do we cross multiply here? No, in J you don't cross multiply. Cross multiplying occurs in problem I, where there's an equal sign between two fractions. That's when you cross multiply. So when you cross multiply, we can say 5x equals 6 and divide both sides by 5. And so x is equal to 6/5. All right, now in this problem with the multiplying, we're going to simply multiply across. So when you multiply fractions, you multiply the numerators together and you get 3x, and the denominators together and you get 10, and we're done. No cross multiplying. You're just multiplying across. The cross multiplying occurred with the equal sign again. Now, here, the error that a lot of students make is they want to just say x plus 3 over 7. You cannot add these two fractions together unless you have a common denominator. So the common denominator would be 10. So we're going to multiply the x over 2 by 5 over 5, because 5 over 5 is just 1. When we multiply the numerator by 5, we get 5x. When we multiply the denominator by 5, we get 10. So now we have 5x over 10 plus, here we're going to multiply the numerator and denominator both by 2. So we're going to get 5x over 10 plus 6 over 10. And so our final answer is going to be 5x plus 6 over 10. Okay, let's move that up and let's do these last 4 problems. Of means multiply in math. So many students see a problem like this and they're like, I have no idea how to do that. But really, of means multiply. So all we're going to do to get 1/4 of 3/5 is we're going to take 1/4 times 3/5. We know we multiply across, so our answer is 3/20. So 1/4 of 3/5 would be 3/20. Okay, this is on here. We've done some like this recently. You take the square root of both sides. The reason it's on here is a lot of students forget plus or minus when they take the square root of both sides of an equation. Don't forget your plus or minus, super important. Okay, the error here that often occurs is students want to just divide out by an x. But if you did that, if you just thought, oh, I can divide both sides by x, you would get x equals 1, which would be one of your answers, but not both of your answers. So the common error is dividing by x when it is one of the only things you can't do when you do something to both sides of an equation. We cannot just divide by a variable or we're likely to lose one of our answers. So we can't do that. What we have to do is move everything to the left. So we have x squared minus x equals 0. Now we're going to factor and solve. So we're going to factor and use the zero product property. First step in factoring is the greatest common factor. So we have x times x minus 1 equals 0. Now we're going to see how we get two answers, either x equals 0, or we could also have x minus 1 equals 0, which means x equals 0 and x equals 1. And if we had just divided by x, we would have lost the answer that x is equal to 0. Okay, these are all tricky. I just want to make sure you know how these exponent rules with negatives work and so forth. Let's first rewrite each of these 4 expressions in a simplified fashion. So -5 to the second is -25 because only the 5 is getting squared and the negative sits in front of it. So the -25 is the value of the first one. Here the negative is getting squared as well. So it's -5 times -5. So it's a +25. This means 1 over 5 to the +2 because negative exponents can be turned into positives by putting them on the other side of the fraction line. So this is 1 over 25. This last one is going to be a negative because of that negative is not getting raised to the -2 power, only the 5 is. So what we're going to do there is we're going to say -1 over 5 to the +2 because we're putting the negative exponent term onto the bottom, or the factor. So 5 to the -2 is the same as 1 over 5 to the +2, but that negative is still sitting there. So the answer to this one is -1/25. So now I'm going to underline our 4 options, and we're going to now put them in order from least to greatest. And I'm going to do that in another color just to show you. So the least one, the least is the -25. So we're going to start with this. So I'm going to write the least number is -5 to the second. So we've taken care of that. The next least would be the -125 right here. So that's going to be -5 to the -2 power, and we're done with this one. The next number going in what's called ascending order is the 1 over 25. So the 1 over 25 is really 5 to the -2 power, and we're done. And then by default, the last one that we can possibly write is -5 squared, and we're done. All right, so This was a big overview of a lot of common mistakes. I went pretty quickly. Feel free to email any questions if you're not sure how we got any of these answers. And please do problem 2. Lots more mistakes ready to be made on problem number 2 of lesson 33. Thanks for joining us at Engage Math.